Hello everyone, my name is Vivek Srivastava. I am working as an assistant professor in computer science and engineering department in ABES Engineering College, Ghaziabad. Today I am here to deliver a lecture on the understanding the concepts of K nearest neighbor algorithm, which is also known as KNN algorithm. It is a very important part of machine learning techniques because we can solve a lot of problems related to classification and regression with the help of machine learning, with the help of k nearest neighbor algorithm, which is also a part of machine learning algorithms. So let's take the look what is the concept of KNN algorithm. So basically, if I talk about the basics of KNN algorithm, so K nearest neighbor is one of the simplest machine learning algorithm based on supervised learning technique. Since this is supervised learning technique, so we can solve the problems related to classification and regression tasks. And in KNN algorithm, it assumes the similarity between the new case data and available cases and put the new case into the category that is the most similar to the available category. Okay. So this is the basic idea of KNN algorithm. And if I talk about the basic the problems which can be solved using KNN algorithm. So KNN algorithm is a non-parametric algorithm. This is a very important concept, which means it does not make any assumptions on underlying data. Okay, this is a very important point. This is a non-parametric algorithm. Second thing, this is also called a lazy learner algorithm. Lazy learner algorithm means it does not learn from the training set immediately. Instead, it stores the data set and at the time of classification, it performs an action on the data set. So this is another important concept of KNN algorithm. In KNN algorithm, we use we use distance metric, and for distance metric, various distance calculation methods can be used like Euclidean and Manhattan. But Euclidean distance method is very simple. So in our example, I will use Euclidean distance method. Now, this algorithm is very useful in the case of prediction, like what is the class, what will be the class of the new data points. So I will take an example by which I will explain how this work. Okay. So this is the example of KNN. Suppose we have 5 points, as you can see in the diagram, and two data points x1 and x2 belongs to the various classes. Like x1, the coordinates of x1 is 2.0 and 3.0, and it belongs to class 3, class 0. Point 2 have two coordinates 2.2 and 2.8, and it belongs to class 0. Similarly, point 3, point 4, and point 5 can also be seen. Suppose a new data point arrives in this data set. At sixth row, we have the coordinates of new data point, and you have to predict the class of the data point according to the given data set. This is the whole working scenario of KNN algorithm. So how will you calculate? So first of all, let's have the data for which we have to predict the class. So the task is given in this example. Let's say we want to classify a new data point which features 2.8 and 3.5. 2.8 and 3.5. For 2.8 and 3.5, we have to predict the class of this data point. And here it is given as k is equal to 3. So what is the meaning of k? Basically, in KNN algorithm, k represents the number of neighbors. Suppose there are 5 data points and we have to add the sixth data point. So point number 6 will have 5 neighbors, but in 5 neighbors we have to choose only 3 neighbors because here the value of k is given as 3. Okay. Now let's put the formula of Euclidean distance. If we write the formula of Euclidean distance, then Euclidean distance is equal to square root. We have to find the values for 2.8 and 3.5. 2.8 and 3.5. So how will it will be written in the formula? Let's have a look. It will be written as 2.8 minus the value of first data point, that is 2 square, plus 3.5 minus 3.0 square. So in this way, we can calculate the distance for every data point with respect to new data point, which is 2.8 and 3.5. So after calculating, if I tell the calculation, the values which will got the after calculation, the values will be distance to point 1 is 0.94. Similarly, 2.8 minus 2.0 square plus 3.5 minus 3.0 square root. Okay. Similarly, the value distance to point 2 is 0.922, and distance for point 3 is 1.346. Distance to point 4 is equal to 0.807, and distance to point 5 is equal to 0.538. So we have calculated the distance of the new data point with respect to every neighbor. But in this case, we have to consider only 3 neighbors, since the value of k is given as 3. So the 3 minimum distances out of 5 will be chosen. So what are the minimum distances? If I choose distance to 0.538, this can be chosen, and 0.807, this can be chosen. 0.5, 0.4, let's write it here. 0.5, 0.4, and 0.2. These are the points which is much closer to the new data point, because they have very less distance in comparison to others. So this is the explanation of this. Select the k nearest neighbor based on the smallest distances. In this case, k is equal to 3. So we choose the 3 nearest points, 5.52 and 4, as I had told earlier. So determine the class labels of these 3 nearest neighbors. So 0.5 belongs to class 1. Let's have a look on this diagram. 0.5 belongs to class 1. 0.4 belongs to class 1. 0.2 belongs to class 0. So let's write it. 0.5 belongs to class 1. 0.2 belongs to class 0. 0.4 belongs to class 1. Perform majority voting among the k nearest neighbors. So out of 3, 2 data points are belonging to class 1. So 2 out of 3 neighbors belong to class 1. So the predicted class for the new data point will be class 1, because out of 3 data points, which are the nearest neighbor of the new data point, out of 3 data points, 2 data points are in class 1. So the new data point will be associated with class 1. So this is the whole scenario of k nearest neighbor algorithm. In this way, we can solve a lot of problems related to k nearest neighbor algorithm. So the KNN algorithm predicts that the new data point belongs to class 1. This is the answer. This is our answer, and you have to perform only this only. Okay. I think this is very simple algorithm. Just try to remember the formula of Euclidean distance. You have to take the square root of observed value minus actual value square plus observed value minus actual value square, and after calculating the distances of the new data point to the given data points, you have to select the k points, as k is given here at 3. So we have selected only 3 points. if k is given as 5 or 2, whatever the value of k is given, you have to select only those data points. Okay, and the majority of the data points belong to which class, the new data point will also go with the same class. In our case, majority of the data points are associated with class 1, so the new data point will go with in class 1. So we can say that the new data point 2.8 comma 3.5 will come in class 1. So this is the whole application of KNN algorithm. I think you got the idea of KNN algorithm. Now let's talk about the use cases where we can apply KNN algorithm. The real world applications of KNN are recommendation system, like in Amazon, Flipkart, and Netflix. We know recommendation is coming time to time according to our search history, and anomaly detection, handwriting recognition. These are the some common areas where we can put KNN algorithm. Okay, and let's talk about some pros and cons of this algorithm also. So if I talk about the advantages associated with k nearest algorithm, so this algorithm is simple and easy to understand. As we have seen here in the previous example, it is very simple. No complex model training or parameter turning required. Okay, effective for problems where the decision boundary is non-linear or irregular. It is good for a small data set, we can say that. And if I talk about the disadvantages associated with k nearest neighbor algorithm, so computationally expensive for large data set, because it will take more time for calculating the distances, Euclidean distance from each data point. Okay, so calculate a lot of calculation will be done there, so it will be very complex. Sensitive to the choice of k and the distance matrix, so we have to be very careful while choosing the value of k, because number of neighbors is very determining in the case of KNN algorithm. And this algorithm, yeah, or this method is not suitable for high dimensional data. So it also a problem. Curse of dimensionality is also a big problem associated with KNN algorithm. So that's all from my side. I think I have explained the basics of KNN algorithm and features of KNN algorithm, where we can use KNN algorithm, and what are the what type of numericals which can be solved using KNN algorithm. So I hope this concept is clear to you, and thank you for watching this video, and I'm very hopeful for delivering new content or next content in my next video related to machine learning. Thank you so much for watching this video. Have a good day.